Hello, Mahmoud. Hello, Mike.
Hello.
Hi, Mahmoud.
Hello,
Hi,
Mike.
Caio.
Hello, Caio.
Thank you for joining us live.
Yes.
So, are you an iOS developer?
Yes, I am iOS developer for 4 years. 4 years, my experience in iOS only, but in software I have 6 years.
Awesome. Great. How can we help you?
I want to know how to make unit test with RxSwift to test API, which best practice to test API, test server or make monkey data, which is the best practice. And I want to also want to best practice to how to use solid principles.
Okay. First of all, unit tests with RxSwift or combine, which is pretty much the same principles.
Okay.
We have a mentoring session about it. I don't know if you've seen it. iOS Dev Mentoring number 008, where we show it in detail. Watch test drive some ViewModels and services. And we show how to mock, how to replace network connections with values. Check it out. But we can have a quick review today.
Okay.
I highly recommend you watch this session afterwards.
Okay, I will. Okay.
It's on YouTube.
Yeah.
It is, right, Mike?
Yes.
Yeah, it's on YouTube. Okay.
Exactly.
Is the font size good? Can you see it?
Yes, I can see. Thank you.
All right. So how to test with those reactive frameworks? Here, let's use combine, so I don't need to download RxSwift. But you can follow the same principles.
But again, it's exactly it's exactly the same idea.
Okay, let's create an example here. Let's say we have, I don't know, some ViewModel. And he has some kind of publisher. Let's create a one here, like a value subject. Current value subject. But this could be like stream, like a publisher that is loading something from the network, for example, or from a database. Right? It doesn't matter. This is just an example. Let's say it emits an integer. It never fails. Give an initial value, 0. Something like this. As you can see, the string that is mutable, like this, I usually hide it as private, so clients cannot inject values into the stream. Make sense?
Yes.
And I expose usually a publisher that is read-only. You can only read from this publisher, for example, like on any publisher. Not inject values into the stream, but you can read any values that are pushed into this publisher. That is published in the publisher. And let's say we want to convert the integer to a string. Here, let's say value subject, map. So I'm considering you are a bit familiar with RxSwift and like map, flat map.
Yes.
Okay.
Come back to map. Yes.
Let's just return like any string. Let's not do any logic here. Erase to any publisher. Let's say we have a code like this. How can we test it? That this mapping here is doing what we're supposed to do. Again, it could be receiving some data from the network and then mapping it into ViewModels. You know, in this case, we're just mapping an integer into a string to simplify the case here. How can we test that? Well, let's create here our ViewModel. And let's say we need a way of injecting a value there. So if we have a method like set value and we pass an integer, let's say 1. Set value integer and injects the value here. Send. We would like here to test that the output is the formatted value. like
Yes.
1 in this case, right? So it's pretty much converting the integer to string. But it could be much more complex logic in the ViewModel, like converting a date into a string or so on. So we need an output to be able to test, right? We have an input, 1, and we need an output or a result. Now this result, we assert the value, right? That's how we write unit tests. Giving a certain input, I expect a certain output, right?
Yeah, right.
The problem is that when you're using a reactive framework that provide these publishers APIs, you cannot just easily extract the current value from the publisher. You need to subscribe to the stream and wait to get a value. And this value may come asynchronously, it may come in the future. It's a sequence of values you're receiving to the stream. So you need to subscribe to this publisher. Like ViewModel value publisher, and then you sync or sync to receive values now. Let me show you the API, which in RxSwift would be observe, I believe.
Yes.
Right. So you're subscribing to that.
Subscribe. Stream. Yes. Subscribe in RxSwift. Yes.
And here you get a value, and then you can say, well, result. Now we can put a assertion here. The problem is, how can we guarantee that this closure was called in the test? Because if this closure is not called,
the test is going to be green.
The test will pass because there's no failed assertions. But actually, it never got here. So we will need to create we will have to wait, for example, for this closure to be called before we finish the test. One way to do it is to create an expectation. Wait for result, something like this. And then you say wait for expectations with a timeout, let's say, of 1 second or 0.1 seconds. And here you say fulfill.
But if I make expectation for fail, I think it's take a lot of time when testing if I have a lot of.
Absolutely.
Yes.
Yes. And we'll solve it. We'll solve it.
Yeah. Okay.
Why? Because let's say we run this test now. Let's see what happens. Never completed. We need to hold. A reference. We need to hold a reference to the subscription. Otherwise, it's canceled immediately. Just like in RxSwift, you usually add the subscription to a dispose bag.
Yes.
If you don't hold a subscription, it's canceled immediately. Right, let's see. Can we run the test? Boom, it failed. So it's running now, but it failed. It failed because we're not mapping. We're just returning an empty string, right?
Yes.
So now we can just return 1 here.
1.
Let's run the test. Let's say we want to make sure that it works not just with 1, but also works with 2. And again, we need to do the same dance here with
look at that.
Another expectation. And now let's say wait for 2. Run the test.
I guess 31 can go away.
We want to wait for this one to finish, then we'll execute the second one.
The second one, yes.
So let's say wait for expectation 1. Amount 0.1. 2. Array.
All right. Yeah.
Multiple calls made.
Oh, that's XP2.
Because it's calling this twice now.
Oh, okay.
So it doesn't scale. What I'm trying to say is that
Yeah.
using expectations in asynchronous tests, it doesn't scale. And it makes your test very slow as well.
Yes.
What you can do instead is to create a helper, like a spy. Here, quickly, a state spy or value spy, something like this. We initialize it with a publisher. Say any publisher. In this case, what is the type? String never. Like this. And here we subscribe. Publisher. Dot sync receive value in. And we capture this value now in a property. So private setter, so it can only be set internally here by this class, privately. Say all the capture values. So this spy will capture all the values created in the test. Values dot and value, like this. Let's also capture self here.
Yes.
Right, and here we can store sellable. Or we can actually just hold here private var sellable. Sellable. We just hold a reference to it. So as long as the spy class instance, as long as you hold a reference to the ValueSpy instance, you will hold a reference to the subscription. So here in the test, you can create your ValueSpy. Let's say let spy, because ValueSpy ViewModel dot value publisher. So it's gonna spy every change that happened in this publisher. We can write some tests now, assertions. What is the initial state we expect for the value publisher? It's 0.
0.
When you set it to 1, it should be
1.
But it's an array. So spy values should be 0. When you set to 1, it should be 0 and 1, right? Because remember, you are capturing the sequence of the stream, all the values that were captured in that stream. Because that's what a publisher is, right? It's like a sequence of events, of values. And you don't need any of this. So when you set it here to 2, now the sequence was 0, 1, 2. We run this test. Optional. All right, what happened here? Oh, it's always returning 1.
Yeah.
Now let's implement the value. We're just mapping integer to string, but again, this could be a bunch of logic here. And now it's passing. So the idea is the same as writing unit tests for anything, input, output, right?
Yes.
The only difference is that when you're testing a publisher is a sequence of values. And you need to capture that sequence and then assert the transition. It started 0, then 0, 1, then 0, 1, 2. And you can see the evolution of that sequence over time. Without timers, without waiting for a value to be sent. You just capture that somehow and you assert them. The only difference is that you get this value pretty much like asynchronously.
That's it, yeah.
Again, there's much more to it. You can see in the mentoring 008.
Okay, a good idea. Okay.
Yeah, but this is just a simple example. And if you're using something like RxSwift, they provide this kind of spies, this kind of test helpers for you. Just check the documentation. They provide all this kind
we
of things
can
for
say
you.
ValueSpy like a Moki data, right? Like a Moki.
Yeah, you can do it.
Yeah.
We show it here. How to replace network requests with like canned responses, right? Something that is already pre-made. So you don't need to actually make a network request to test your code.
Okay.
And we show you there as well. And that's the idea, you know, avoid asynchrony, avoid timers, anything that makes your test slow. Try to make it smooth, fast, in the same thread, no complexity.
Okay.
Make sense?
Makes sense, yeah.
And it's pretty readable as well. You can see the evolution here. Precondition, post conditions. All right. And the other question you mentioned was?
What the solid principles?
Sorry.
Okay, what specifically about the solid principles?
Yeah, in a solid principles, when I make a model and a view model, okay, model should have functions on only properties to store data only. You know, in single principles should only one reason to change for clause, okay. What's the best practice to do it? If I make stock model and check quantity, this function will be on model or view model.
Okay. So you have a stock model? Yeah.
Yes.
I think. So let's say you have a stock model.
Yes. Struct stock model.
And then you have a function check quantity, you said.
Yes.
Check quantity.
And it returns something, whatever. Okay.
Return integer. Okay. But this struct is make a codable parsing data. Okay.
Okay.
Yeah. The best practice to make this check quantity in this model or view model.
Okay. They also have a stock view model for the view, right?
Yes.
Converts.
Yes,
yeah. Okay, so let's say here, if you have like a date, you would have in your view model, if your view needs to present a date, here your date will be a string. So the stock view model will translate the model data into presentable data that can be rendered in the UI, right? So like here is a human presentable data, and this is a computer presentable data.
Yeah, let's say.
So it depends how you organize your application, and if it's a presentation logic or if it's business logic. Because if you have a model that represents business logic, the business logic all the business logic should be there regarding the stock, right? Everything that's related to that stock. Now, when there's presentation logic about that stock, it should be in the view model. So you need to ask yourself, is this logic for presentation purposes or for business logic purposes, right? So if you say, well, you need a function here to convert this integer into a formatted string. For example, if you have 1,000, you will convert it to 1,000, like in Europe, or 1,000 in some countries they use dot as the decimal or the thousands, separator.
Yeah.
So all of this is presentation logic, right?
Yes.
Like converting an integer to a string and presenting something that the user can understand. That's presentation logic. It goes into the view model. Now, logic between, like, I don't know, doing some business specific logic about this stock, like calculating some formula, like future value of the stock, like something like this can be done here.
Okay.
But converting that value into something that is presentable goes in the view model.
Yes, I like that expression. You said it. Any business logic for stock will be in model stock, like,
Yes.
right? And the presentation logic will be in view model.
Yes.
Yes.
Yes, because view model just talk with view only,
Yes.
not, and the
Yes.
view model talk with model, and the model not connect with view.
Yes.
Yes, good, makes sense.
Yeah, should also pay attention to this codable conformance there, because this has nothing to do with the stock. That's probably
Business logic.
Yeah.
Codable is an infrastructure detail because you need to decode it from JSON or from plist or something like that. So I would even separate, if there's something that's not specific to the business logic, like coding and encoding and decoding, into a separate one. Like let's say if you're talking to a remote backend, to load this stock data, I'll probably create a remote stock struct, or like the API stock or something like this, that represents the data that the API returns to you, which is a bunch of like primitives, integers, and strings and dictionaries, right?
Okay.
Now we convert that dictionaries, that JSON, into this API stock, which is just data. And out of this data, I would create my stock model that contains the business logic. And after performing the logic and calculating whatever I need to do with that stock, and I want to present something to the user, I convert that data into a stock view model with the presentation logic. Thus, my business logic is not concerned about encoding, decoding, or presentation logic, only with the business rules.
Only with business. Okay. I should to make API for API stock for API the codable or encodable or like this, right? And in business domain, I make stock for business domain. Okay.
Yeah, and maybe you even have one. Let's say and then you have a cache with core data. You can even have another one in a core data like persistent layer, where you have a
local
CD stock, which is a core data stock that inherits from an S managed object.
Yeah.
For example. Sometimes here you have you receive here like an integer, let's say, I don't know, value. Or here you get like an integer, but then in core data, you store it as a int 32, but in your actual model, you want it to be a decimal. Because different models, different layers will have different representations of that data that make sense to that model. When you're receiving some data, sometimes here it's a float. Let's say you get a float from the JSON response, but you store it as a float 32 in the database. But when you perform in logic, you want it to be a decimal to perform and can you see that they have different representations? And when you present it to the user, they're both strings. That's why you want to separate them, because although they look the same, they're not. Because in their own layer, they represent the same entity, the stock that has an identifier, right? They are the same entity, but with different representations of that data it holds. That makes sense to that layer.
Okay. Function will call API in stock on view or view model.
Say that again, please.
Function will make encodable. Codable, okay? Will be in stock model or view model.
Decodable. Do you mean decodable?
Yeah, I make function here that's parsing data. Function that's parsing data from server.
It's probably going to be here in the API. You will have some kind of service, right? Like the API stock service. You will make the network request.
Okay.
Get some data back.
Yes,
you convert data
And the view model
API stock.
use this, right?
No,
Not necessarily.
yeah.
It doesn't have to.
Okay.
Yeah. So imagine like the journey of the data. You know, if you receive it from an API, right? You're going to receive data from the API, and then you want to map that data to an API representation of a stock, right?
Yes.
And then you want to map that to your domain, most probably, to your domain stock. And then if the UI needs that, you need to map that to a view model, a stock view model, right? Because that's exactly what you need to show on screen, right?
Yes.
Yeah. So imagine it as like, you know, as a pipeline. Data, API stock, you know, stock, view model stock, et cetera, et cetera. And if you need, you know, like in between steps, like caching, for example, you know, you can do so.
So let's say the view model. If you want the view model talking to a service that will load the stocks, you can define an abstraction here, like a stock service. And here you define the API that you want. What do you want this API to return? Let's say load stocks. And it has a completion block. Or if you're using RxSwift, I don't know, you can return some observer. Let's say you have a service here. Completion will be escaping the result of what? What do you expect to load here? A stock or a stock API?
CD stock, I think. Stock.
Stock. And it may fail. So let's say, or error. Something like this. So you define here, and this view model needs a service. That you will require it in the initializer, for example. Let's say it has a service here, right? You define whatever API you want. You want a stock. You don't want a core data stock. Those are implementation details. You don't want an API stock. Whoever implements this protocol here will talk to the API, get some data back, convert that data into stocks, and pass it back to the completion block. But that's an implementation detail of that service. They need to talk to a backend API and convert that into domain models or to whatever makes sense to your application. So the view model don't actually need to talk to the API stock or to the core data. You know, only if you want it. If you want. Okay, let's say dynamic. Dynamic. So we have no compiler errors. Makes sense? You create an abstraction to hide the implementation details from the view model. Does the view model only depend on the stock, not on the API stock or the CD stock and so on? So when you want to hide implementation details, you can create a tiny abstraction. Sorry, this should be a protocol. Be a class as well, and you subclass it. Protocol, it's probably better. Make sense?
Makes sense.
So overall, separate. If you have different representations of data in different layers, you can create separate models. So you separate the business logic from the presentation logic. And you can create as many as you want. As many models as you need.
In my layers.
Sorry?
Yeah, in your layers.
Yes, depending on my layer.
absolutely.
I recommend watch the Clean iOS Architecture playlist that we go into detail and for these things.
Part 1 to 7
Yeah.
on YouTube as well.
Okay. Thank
Awesome.
you. Thank you, Mike. Thank you, Xiao.
Thank you.
Thank you.
Bye.
Thank you, Mahmoud.
Bye. Thank you.
Take care. Bye.
Yeah, bye.